These numbers are basically, how many cells. This is the surface of cells. These are faces. This is a total cell number. Okay, this I think Carl this morning talked about this. But when you do parallel computation, maybe it's okay, but I think maybe an issue of memories, and then the code, give you can estimate this, but just like this. Let's see, I have to comment it out, this one. Because you decompose, you have divided. It's not fully divided, it's a small number. So as I'm using 32, you can look at here is this one. Yeah, it's 32. This is the single CPU. We don't need to do that. But on the right-hand side, you can see I actually use these numbers. Okay, the total number is only just 3,000, right? Like this. Because just you have to change these files to do a compilation. These are things you need to know a little bit. So now we just look a little bit, then we go back, and there is a folder called work. Basically, it's where you do the compilations. We can go there, do the work. So I already did a lot of them, but I think I just save them. Move these kind of things. Let's see this one, because we want to to know exactly how to do it. No, it's like this. This is basically the folder that where you do the compilations. And I'm sorry, I need to go back and not going back. I think it's the source code. So we know that the modular files point to the parallel computation. So the first we do is compile the code in parallel computation. Okay, this we do it, and the way we do it is quite simple. Basically, use the maker files, right? I think when you use Linux, basically this kind of.
What did you just do with the moving and what did you just do with the moving of the files and the saving of?
This kind of compiled executable that I did before.
Oh, okay.
But I want to show you how to do it.
Right.
So we
So you have to take the old ones.
Yeah. I just put it there, in the bank.
You.
Yeah. Right. This basically. So we can look a little bit. I think. You don't need to look at this, but just how to work. This basically the maker files, right? How to do the things. I think inside there is a kind of pre-processing. I think when you do the maker files, basically just show you just like this. You don't need to work on this. The only things probably if you are lost, I think there's somewhere probably there's something I want to show you, but may not be there. Basically, this is an option. You can make like this, make a PWM. This is basically the option. You compile the code for parallel computation, or just WQM. This would be use a single CPU. And this one is when I show you that prep, right? Preparing the program used to decompose or combine. Basically, the three options we just need that. So now you just I think I just make, because we are doing this one, right? Parallel computation.
Okay.
So it's it
So
just
it automatically knows to go to the GNU make file? You don't need to do make minus?
automatically.
It knows that.
Automatically. The make just automatically link to that.
So-
that
Well, that's
file.
interesting.
So basically, you have a make file,
Yeah.
and you compile for whatever case you want,
Yeah.
right? And then you get hopefully something that works.
Yeah. Yeah.
And this uses specific compiler, the PGI or Intel?
Oh, very good question. I think it works at least for the G Fortran.
It works for G.
Or here we are using Intel.
You're using because usually the compilers have different switches.
Yeah.
Like in some cases it's -O, as other cases it's -F. So
Yeah,
that's-
yeah.
So you do have to be.
You have to set up that. So you can see that's a very good question. Basically, this compiler I'm using, you can see MPI i4 is Intel, and MPI this you must have the package for parallel computation.
So MPI i4 is actually a specific Intel compiler for parallel processing.
Excellent.
Okay.
You got yeah.
But does it work if you use the GNU?
It should work. But you have to have the MPI GNU Fortran, G Fortran.
But you would change all your MPI i4s to, I'm assuming, something like
Exactly.
G4s.
Yeah, exactly.
So you must have a make file for the GNU compilers.
No, but we can do one.
Okay.
We can do one, but you have to first, install the, we call it the MPI F90. This, compiler. You have to have that in your computer.
You have to have that
Yeah,
in
yeah.
order to make this work.
Oh yeah, exactly. Yeah.
I see. So
Well, you either need an MPI GNU compiler or an
Yeah.
MPI i4.
Exactly.
And actually, I thought i4 automatically, had MPI sort of built into it.
Maybe, yeah, maybe,
Okay.
yeah.
Because the PGI compiler will allow.
Yeah,
Okay.
exactly. Yeah.
To make that make file name, does it have to be GNU make file? That makes
I think sometimes just call make files.
make file.
Depending on your system, how you set.
Well, usually if Linux systems, and again, this might be different, if you do make and don't specify anything, then it automatically looks for make file.
Probably make everything,
If
yeah.
you wanted to do something different, that's why I was asking
Yeah,
about
yeah,
the GNU.
yeah.
I would have thought you would have said
Yeah,
make
yeah,
-F
yeah.
GNU
Yeah.
file.
Okay.
Make-
Yeah. That's you can do that.
Yeah, so do you have
Yeah.
an actual make file, just a
Yeah.
simple make file?
Yeah.
Can you do an LS again?
No, I don't think we have.
So that's why I'm surprised that you
No.
didn't have to
Yeah.
specify the
No.
-F GNU
Yeah,
make file.
I think you are right. You can do, I think, more. I think intellectually maybe like this. I think with the F, right?
-F.
Minus F, I think.
Right.
Yeah. That's what I use to do. But yeah.
Yeah, no,
I think
that does.
it's the same. Yeah. That's yeah.
So this one is different. Okay.
No, it's not. I think it's the same.
No, your version of Linux seems to be a little different. In
you
that if I typed make and didn't have a make file that
Yeah.
my Linux system,
Yeah.
it would say
Yeah.
I can't find make file. I would have had to do make -F GNU
Yeah.
file.
Yeah.
So it's a little
Yeah.
different.
Not quite. I think you see some difference because this time is the make up compile everything.
I'm still really confused.
Everything.
Your new make file that you have there, you're still using the MPI compilers.
Yeah, that's why it's a little confusing.
You have. Yeah, that's a very good question. You can just specify here. I think this file was included code by the maker files, and if you can. Oh, sorry. Okay. Yeah, this file. This is another step. Yeah, is here you define what.
Seen that kind of a thing, so that's how it's doing it. That's interesting.
Yeah.
Say again?
apparently defaults, instead of going to the GNU make file, could you close that again? And then just do an ls. So see that other little file that says compile r flags mk? So apparently when you type make without anything, it goes to that file, which then
Correct. Yeah.
references the appropriate make file properly.
Yeah,
That's
yeah.
different, I've never seen that.
Okay.
Thank you.
I
Now it makes
understand.
sense.
So why did you call it GNU Makefile?
But I just someone sent it to me called genomic files. I think I think it's automatic, right? It depends on your system, but you can use a different one when you dash F, get another name. But you see that, it's automatically, yeah. Make, I think, just direct to GNU Make files.
Okay, so it's basically the same, and the compiler that this needs is MPI4.
Yeah.
That it's using anyway.
Yeah. That's why I'm trying to show you that if we can change anything, we try another one if it works. I'm not sure we have it. So we just do a test here. And this, it's a little bit complicated that basically this file kind of, trying to be smart, but, there's some complication.
Where you specify the compiler that you're using.
Exactly.
Okay.
But depending on kind of what machine.
Right.
Yeah.
So if you change that compiler to PGI, it would attempt to use the PGI.
Exactly.
See where it says compile,
Yeah.
go up.
Exactly.
Intel, right?
Yeah.
Yeah.
So that's how it's doing it. I see.
Yeah.
Thank you.
And I think we are here. The machine type basically
You have the
is.
PGI compiler, you have the Intel compiler, or you have,
Yeah, see, that's interesting. As I said, the PGI, you have the byte swap IO, where the Intel, you don't have the byte swap unless it's specified somewhere else. So I see what it's doing. All right.
So here we try another things. I think it's much.
and is there a compiler type of GNU?
Is this one that I'm trying to do. I think this GNU would be, I think, when you install the MPI package, I think that the default the GNU compiler would be MPI default,
Or
not.
G95?
Yeah, we just try this if it works or not, okay? Hopefully I did, then you can make a clear, basically just delete everything you did. Did not delete everything, but we will do it. This one, this is the parallel, and this one is this is the things, but yeah. Basically, this one does not work. This one, right? This I told you this one single CPU, but we compile with the modular files use 32, so it does not work. You have to go. But that's why I don't do make all,
Right.
Yeah, because you have to go back to the things. And this one, you use it only when you do parallel computation, obviously. Because when you do a single CPU, you don't need to decompose, right? You don't need to combine. You don't need this program. This one, I will show you later. So now, let's see if it works or not. If not, we just return back.
Richard, I'm sorry, so the WQMPP does not require you to decompose? Or is
No, I mean, you have to have that software when you do parallel computation. Okay, if you run it on your PC with a single CPU, it's not needed. You just run WQM, as we did it for the 30 box model. That's it.
But if I have a single machine which has, for example, 16 cores.
You have, if you run it, no, this, I think how to run it does not depending on what machine you have. It depends on what you want to do. And here on the cloud, we have so many CPU, right? But we still can use only one single CPU to do the job. It's not depending on your machine, but on your machine, if you have a 64 something like that, you want to run on parallel mode, you have to have the WQMPP kind of preparation.
To run it.
Yeah,
So that's the one that runs the parallels.
yeah, yeah.
But do I have to decompose the stuff in order to run WQMPP?
No. I think the WQMPP, what is the dot? Is a dot the decomposition.
WQMPP does the decomp.
Yeah.
And then you can run in parallel PWQM.
Excellent. You
Now I
fully got it.
understand.
Yeah, you
I'm
fully got
sorry.
it. Yeah. No, sorry. I think you just, I think ahead of us. We get that point, but it's
okay.
perfect.
So WQMPP is the decomposer,
Yeah,
and PWQM is the parallel compiler.
yeah,
And parallel compiler flags.
Not to be
yeah.
a pain in the neck about it, but why not rechange WQMPP to
Yeah.
comp or
Yeah,
something
yeah,
like that?
yeah,
Because
yeah.
I was confused by that as
Yeah.
well.
I think a PP kind of preparation and a post-processing
Well,
too.
but it's got the
There are two P.
WQM, which is more the quality model.
Yeah,
That's the part.
yeah,
I mean,
yeah,
otherwise, just
yeah.
call it PP. for
Yeah.
parallel. I mean, seriously,
Anyway, yeah,
it is
there's a
confusing.
yeah.
So that's the
Until you do it once.
preprocessor.
Mm-hmm.
Right. PWQM is the compiler.
Yeah,
And you have to run them both in order to make a single run of the model.
yeah.
So you have to run them both every time.
Yeah, you basically run 3 times. First, I will show you. First, you run WQMPP 1 time, which does decompose the things.
Right.
Then you run PWQM to run real the model. After that, you run another time WQMPP to combine everyone's result.
So
So there are 3 steps you
is
run.
that for each time step?
No, for the whole things. For the whole things.
QMPP is both the preprocessor and the postprocessor.
Yeah, exactly.
Puts all the files together at
Exactly.
the end.
Excellent.
But
Oh.
when you have multiple domains, and
Yeah.
the domains need to talk to each other.
Yeah.
That is done within PWQM.
Exactly. Excellent. Fully got you got
And
it.
in the make part, PWQM is the path to the GNU make file.
Yeah.
So if I only want to compile it to a single CPU, I put a make WQM.
Exactly. You fully understand. I'm happy with that. So we just trying that you suggest this it works. No, it does not. I'm sorry. So we just probably
Okay.
it would be too hard to make it work. So
right.
I think we just go back to our default. There. Okay. Fine. Each model, depending on the developer, they kind of change a little bit how to do the things. And this file, sometimes just embedded in the make files, not independently, but Oh, okay. Now we are set. So let's see, we have nothing. We just make the ordinary PWP and that's good. It works.
So you just made the executable.
Yeah.
Now you will execute it.
Yeah.
And then you will run the WQMPP
Yeah.
again.
Yeah.
Okay.
So for the time being, I did not do the WQMPPs. I want to check something. This is complicated, I think. In fact, it's not. It's this program. I got a headache. Kind of got a headache, I think. Yeah. Okay. So I think the other module define the dimension for the, preparation, decomposition, and combination. You have to be careful with this file too, because somewhere you have to specify beforehand how many CPU you want to use. It's not all the system like a Schism or FVCOM. You don't need to specify. You can use it as a number, but here you just say, I think I developed pretty earlier, is this one. like basically this parameter value just tell the program how many CPU you want to use. You have to be careful. If you want 48, you know, specify 48.